Alrighty, so for lesson 29, what we're talking about is lines and what you know about them and using them to help make predictions. So here, our question says you can recall how to identify the rate of change, slope, and initial value, y-intercept. So we're going to examine the function f of x equals 2.8x plus 45, and we're going to identify the rate of change and the initial value. So, to do that, what we need to remember is f of x. Another way that we can think of it is y. So, we could think of this as like y equals 2.8 x plus 45. Now, this is our equation, which is the same thing as what it was over here. Just sometimes it's easier to see these things when it's written as y. Now, uh, what you have to remember is this is the equation of a line and it's written in slope-intercept form. So slope-intercept form looks like this: y equals mx plus b, where m is your slope or your rate of change, whatever you want to call it, and b is your y-intercept or your initial value. Now we know that's so the y-intercept, we call that the initial value because if you consider an x and a y-axis, if you're on some point right here on the y-axis, what's happening is that must mean your x value is 0 if you're going to be on the y-axis. And so if you're thinking about uh time, maybe time is your x-axis, then time being 0 means you're at the start. So because no time has passed before something happened, so that's why we call it the initial value. So in this problem, this is our m and this is our b. So when we're asked to identify the rate of change, we look at the number to the left of x, the coefficient of x, and that's going to be 2.8. So our slope, our rate of change, we're going to call that 2.8. And then our initial value is this guy here. So our b, our y-intercept, we call that one 45. And that's how you can identify the rate of change and initial value given a function like this, a line.